Okay, you guys, so we're going to get back into this and we're going to be talking about this graph because we're going to be going ahead and we're going to be talking about what this graph means and all of that because you guys are going to be seeing a very similar type of graph on your test. So I want to make sure that you guys know exactly what those graphs mean and all of that. So in this, right, we have mass and we have volume. And we have this mass that is increasing as my volume is increasing, right? So, for the information that you guys can be given, right, is that you guys are going to see that mass is increasing as volume is increasing. Right, so you guys see that both of those things are increasing at a steady rate, and that is what's happening on the slope, right? Because in this slope, you guys are going ahead and you guys are being given the density of it, but we're not going to worry so much about the density. I just want you guys to worry about that those things are increasing. So next thing, they ask you to go ahead and to kind of draw some information from the graph. And you guys are going to be expected to do the same thing. You guys are going to look at this and what is the expected mass of something that's 45 centimeters to the third of a same piece of substance. So we look at volume and we know that volume is centimeters to the third. So we match those units, right? And we'll see that our volume does not go up all the way to 45. So like 45 is somewhere way out there. So we're going to have to go ahead and we're going to have to make a pretty good estimate of it. So my suggestion for whenever you guys are doing sort of this stuff like this is we're going to go ahead and we're going to find the half of 45, right, which is going to be what? It's 4. 0, bring down the 5, 4, it's going to be 22.5, right? Yes. So it's going to be 22.5. So we go ahead and we look at our graph at about 22.5. So 21, 22, 23, 24, 25. So 21, 22 and a half is going to be somewhere around here-ish, right? And we'll see that my mass of that is 20. If I go ahead and if I double my mass, right, so it's going to be 20 times 2 is going to be equal to about 40 grams, right? And the way that I did that was I went ahead and I halved the mass that they're asking me first. I definitely have the half on there. I just went ahead and I made a rough estimate of it, right? It's about 20 grams, so you guys could probably assume that it's going to be about 40 grams worth of it. Okay. So just a couple of density problems and then a few things that I want you guys to make sure that you guys do know for your quiz. Test. Okay, so this gives you the density of mercury. You guys don't have to worry about this because I've took a lot of these questions off of the test. I'm going to be testing you guys actually on density next time. But if you guys really, really want to solve it, it's D is equal to M over V, right? And you guys put the density here, right? And you put the volume here, and you guys are able to go ahead and you guys are able to solve those problems. The main thing that I want you guys to make sure that you guys do know is some of the nutrition facts labels and that you guys are able to interpret those. So very similar, very similar to what we were doing in class earlier, in which we have, I'm just going to go ahead and I'm just going to go back into this. So we had our, let's go ahead and let's pick a different chip. So we're going to go ahead and we're going to look up Lay's potatoes. So if we go ahead and if we look up a nutrition label for potato chips, right, I'm just going to pull one off the other computer that I have. And we are going to go ahead and we're going to make sure that you guys go ahead and do that. So this is for Lay's classic potatoes. So we have this thing happening. So in this little bag of chips, so we have the serving size is one thing that you guys are going to look at. Oopsies. The serving size is 1 ounce or 28 grams. And then it also gives you like blank number of chips, right? It's 15, in case you're wondering, right? And then we are looking at calories. So in this 1 ounce or 28 grams, there are 160 calories, right? You guys are going to be expected to go ahead and to come up with your own amount of calories if I give you any sort of gram sort of deal, right? So you guys will see that in 28 grams, there are 160 calories, right? Now, if I'm going to ask you how many calories are in, let's say in 5 grams, right? You guys are going to go ahead and you guys are going to set this up, right? It's a simple cross multiplication problem, right? And you guys will see that I have calories with capital C. So I'm going ahead and I'm solving them, and what I'm doing is that I am going ahead and I am cross multiplying these together. So 28x is equal to, let's go ahead and let's do it in another color, 160 times 5. Whoopsies. So I would go ahead and I would do that on here. So 160 times 5 is 800. So that's where I got those numbers from. I'm going to divide by 28 to go ahead and leave my x by itself, right? And I would get 28.57 calories, right? So that is what you guys are going to have on there, is that you guys need to make sure that you guys can go ahead and you guys can solve problems like this instead, right? The other thing that you guys need to do is you guys need to make sure that you guys are able to do your scientific notation, right? So I already gave you guys notes on that, and those are very, very thorough notes on how to do scientific notation, right? So for example, if I ask you to go ahead and to put this number right here, so if I asked you guys to go ahead and to put 28.57 in 2 sig figs, right, in 2 sig figs. So I look at this, right, I'm going to pick my first 2 sig figs, which is going to be 2 and 8, right? I picked off my 2 and my 8. Then I'm going to go ahead and I'm going to check if I have to round. So I look at this next number that's right here, right? So I look at that 5 and I look at that 8 and I'm like, okay, I'm going to have to round. So now my number is 2.9. I'm always going to put the decimal point after the first sig fig, right? And now I'm going to count how many times I move that decimal spot over. So I go ahead and I look at that and I see that I moved my decimal spot over once, right? So it's going to be 2.9 times 10 to the first power, or it's going to be 2.9 e to the 1, right? Both mean the same thing. Again, this number right here, it's going to be positive, right? Because I moved it to the left, right? So anytime you move it over to the left, it's a positive. Anytime you move it over to the right, it's a negative, right? So for example, I'm going to do a super duper small number because I know that I have some people that do not like these numbers, right? So in doing this, right, I see that I have 3 significant figures here. I'm going to go ahead and I'm going to express this number in 2 sig figs, right? So in 2 sig figs, I'm going to go ahead and I'm going to express this number. So I look at my number and my first 2 sig figs are 5 and 9. And the reason I know that is because all these zeros that are before the first significant figure are not significant, even though they are behind a decimal point. They are not significant. So we are going to go ahead and we're going to put the decimal point right over here. And now we're going to go ahead and we're going to count how many spaces we go ahead and we moved over. So you go 1, 2, 3, and 4, right? So it's going to be times 10 to the 4th, right? And since I went ahead and since I moved over to the right, right? So since I moved over to the right, it is going to be negative, right? So those are the things that you guys are going ahead and you guys are looking at. So make sure you guys study sig figs. Make sure you guys do scientific notation as well. And good luck. And I will see you guys next time.